Factors on which the lateral displacement depends on. So this is what we are trying to learn. Lateral displacement or lateral shift, both, they mean the same. So there are four factors which we are listing. Thickness, angle of incidence. These are the main things that they will ask. Refractive index and wavelength of light. This you guys need to keep in mind. So these are the factors. I would like to make, this is the first thing, the thickness part, very clear. So what does the thickness of glass slab mean? See, this is a glass slab and right, three-dimensional stuff. So it has your length, breadth. So let me change it a bit. Okay, yeah, that'll be better. So you have your length, breadth and height, right? So left to right is your length, away from us is your breadth, and from the bottom to top is your height. Okay, so generally height is your thickness. Generally that's what people talk about, thickness. So when they tell thickness, that's what it means. But when we are talking about this particular experiment, the thickness means altogether different. So the height factor is not what we are considering. We could have done that actually, but we are doing something else. So what we are trying to do over here is we're keeping the glass slab in this way. Okay. And putting our pins over here or over here and trying to observe the lateral shift at the other end. Okay. So when we are observing this way, right, when we keep the pins over here and observing the lateral shift from this end, right, the thickness will be, if I call this as ABCD, the thickness will be from B to C. But if I happen to keep the pins over here and see the shift at this end, the thickness will be from A to B. So the thickness depends over here, depends on where the lateral shift is happening, from which face to which face. So here the face, right, FAC, face, the face of the lens, that is not lens, sorry, slab which is involved is AD and BC, these two ends. So the thickness is from A to B. Okay, so the thickness depends on from which side to which side the shift is happening. Right, so this you need to keep in mind before we understand how it affects. So I'm not only listing it, I'll be talking about how it affects also. Right, this is a bit of more of information, but again, it will lead to better understanding, right? So how is that we are doing this, right? How is that we are learning this? I have a base case. So with respect to this, I'll be comparing the other two cases wherein I'm varying the thickness and angle of incidence. So in the base case, I kept the angle of incidence to be 40. Okay, I1, I'm calling it as I1, which is 40 degree, and the thickness, right, thickness 1 is from, if I call this as ABCD, right, from B to C is your thickness. And this is not something which I've drawn just like that, right? This is something that I have done practically. So this is the practical version of what you're looking at, and this particular paper I've scanned, and this is what you're looking at. So all the experiments, what you're going to look at, all the three are done with the same glass slab, okay, with the same set of pins and all of that, right? And I have scanned it, and you are looking at that. So what is the shift? So the shift happens to be around, right, there are shifts in three different cases. So I'll explain what is we'll measure the shift later. So I'll just explain what is happening. So this is the base case. We have angle of incidence 40, and B to C is your thickness. So in case 2, I'm varying the thickness. I'm keeping the same angle of incidence. So the angle of incidence remains the same, but the thickness is changing. So here my ABCD will be in this way. So here my thickness is from C to D, if not A to B. So this particular thickness is more than the first thickness. Okay, I'm considering a case wherein the thickness is increased. So we're looking at the third case. So third case we deal with same thickness, but the angle of incidence is reduced. Okay, so here the angle of incidence is lesser than the first one, and we can see the thickness, or sorry, not thickness, or lateral shift has reduced. So let us practically measure this so that we are clear with what we are doing. So again, this I've done practically. It's not just something that I'm making it up. So in the base case, right? In the first case, the lateral shift happens to be 1.8 centimeter. So this is 1.8 centimeter, right? 1 and 2, 1.8. In this, it happens to be almost approximately 1.2 centimeter, right? Please have a look. Okay, so 13 to 14, 14.2, 1.2 centimeter. Third one. So you guys measure this. It's a bit small. So this is around 0, 1, 2. This is 2.5. This is approximately 2.4 centimeter. 2.4 centimeter. Okay, so I hope it made sense to you guys what we did. So what is happening over here? We had a shift of 1.8 to begin with. When we increased the thickness, the lateral shift increased. I hope it made sense. See, if I happen to reduce the thickness, the lateral displacement would have been only till here, right? This ray would have not bent to this extent. If I'd further increase the thickness, the shift would have been a lot more. So with increase in thickness, the lateral displacement or the shift is increasing. So this is directly proportional. Okay. Now we are keeping the thickness same in the third case, but reducing the angle of incidence. So we can see the shift has reduced. So what can we tell? With changing angle of incidence, the lateral shift is changing and it is directly proportional. So if I had to increase the angle of incidence, right, the lateral shift would have increased. That's what it means. Okay. So these are your 4 factors. The first 2, I hope you guys understood in very detailed manner. The last 2 is something, actually I can do it, but I don't know, I didn't do it. So that should be done with lasers and all that. Pins also can be done. Third one we can do it with pins. Fourth one we should do with different colors lasers. Okay. Anyways, I'll try to put it in the future, but as of now, please write down the factors and try to do this set of experiments on your own. There's nothing to copy from here. Okay, but yes, you should do all of this experiment. That's the whole point of showing this.